Hello, today we are getting into average atomic mass. So average atomic mass deals with isotopes. And a definition for isotope are atoms of the same element with different masses due to the different number of neutrons. So remember, what makes an element, a specific element is the number of protons, which is the atomic number. If you change the number of protons, it's a totally different element. But if you change the number of neutrons, it's the same element, but it has a different mass. So that's why we call them isotopes. And so an example would be something like carbon-12 and carbon-14. So carbon-12 is one isotope of carbon it would have 6 protons and 6 neutrons. Carbon-14 would have 6 protons and 8 neutrons. And that, again, we add those two together to get the mass number. So those are still both atoms of carbon, just one has 2 more neutrons than the other. So what we can do then is with these mass numbers and with these isotopes is we can actually get an average atomic mass for a sample of that particular element. So if I took a sample of carbon in nature, you would have some of the atoms being carbon-12, some of the atoms being carbon-13, some of the atoms being carbon-14. There's several different isotopes of carbon, so a sample of carbon would have all of those within it. Well, what we can do with that is we can actually get an average atomic mass, which is an average mass of all the isotopes of an element. So this is a weighted average. It's different than a normal average. In a normal average, like in math class, you would add all the numbers up and divide by how many you have. The average atomic mass is actually a weighted average because the different isotopes, there's different abundances in nature. So it's not necessarily a 50-50 split between if something had 2 isotopes, or there's not the same amount of each isotope in a sample. It's going to be a weighted average. It's kind of similar to how we weight grades at school. Tests are not worth the same as daily grades. So when you average your grades, when you get your average, it's not simply just add all your grades up and divide by how many grades you have. You have to take into account the category of daily work and the category of tests and what percentage they are weighted. So we take a weighted average. So not all isotopes are created equal. Some are different. So here's an example problem with silicon. Okay. So silicon has 3 isotopes, silicon-28, 29, and 30. And then their percentages are here. So silicon-28 is 92.23%, 29 is 4.67%, and 30 is 3.1%. So what that means is if I took a sample of silicon and I looked at the atoms, 92% of the atoms would be silicon-28, 4% would be the 29, and 3.1% would be the 30. So how do I get an average of all the mass? So what you do is you're going to do some math. So we take this 28 number and we're going to multiply it by the percent as a decimal. So I move the decimal point over twice. So 92.23 becomes 0.9223. I do 29 times 0.0467. I move the decimal point over twice. And then I do 30 times 0.0310. Okay? So I'm going to do those on my calculator. 28 times 0.9223. And that gets me, if you look here, that's going to get me 25.82. I'm going to round to the hundredths. And then 29 times 0.0467. It's going to give me 1.35. And I'll do 30 times 0.0310. And that's going to be 0.93. Okay? So I have my three numbers that I multiplied the mass by their percent abundance. I have these three numbers, and then I add them together. So 25.82 plus 1.35 plus 0.93. And that gets me 28.1 or 28.10. And the unit here would be AMUs. Okay? And to check yourself, if it's an actual element, to check yourself, you can go back to the periodic table and look to see if the number that you got is close to the actual mass on the periodic table. Okay? Let me, is that a little better there? Okay. All right, let's do one more. Here's another example. This one is an element X that I made up. So in this case, let me make these decimals a little darker. So in this case, I have two elements, or two isotopes of element X, and here's their percent abundances. So I'm going to do 34 point, and if I'm given those decimal places, unlike the whole numbers, I'm going to use all those decimals so that I get a more accurate number. Times 0.732 times 0.268. So I'm going to do, again, 34.0003 times 0.732. That gets me 24.89. And then 36.0002 times 0.268. And that gets me 9.65. And then I'm going to add those two together. And that will give me 34.54 AMU. Okay. There is my answer. And that's how you do average atomic mass.